All right, welcome back. For our seventh session, we are diving deep into one of the most incredible systems in your entire body, your humoral immune system. I want you to think of it as your body's own super smart intelligence agency and a high-tech weapons factory, all rolled into one. It's the system that learns, adapts, and crucially, remembers. This is a really core topic, so let's get right into it. So this is the big question for today. Just think about that for a second. How can a defense system design a perfectly customized weapon for an invader it has never, ever seen before? I mean, it sounds like something straight out of a sci-fi movie, but it's happening inside of you at this very moment. Okay, let's break down how this works.
To really get a handle on the humoral response, we first need to zoom out a bit and see the big picture. Your body has two main security systems, the innate system and the adaptive system. The humoral response, the star of our show today, is a huge part of that adaptive system. You can think of the adaptive system as the elite special forces, while the innate system is more like the general security guards on patrol.
Okay, this table right here. This is absolutely crucial, especially for your exams. So let's walk through it. It shows you the fundamental trade-offs. Your innate system is the first responder. It's fast, it gets to the scene in minutes, and it attacks broadly. But it's not very specific, and it has zero memory. The adaptive system, on the other hand, is slow to get going, but once it does, its response is like a sniper rifle, incredibly precise, tailored to one specific enemy. And, this is the most important part, it remembers. That memory is the key to long-term immunity, and it's what we're really focusing on today. Okay, so let's picture this. A pathogen, maybe a virus, has just gotten past your first lines of defense, like your skin. The invasion has officially begun. So what happens next? The very first thing that happens is that unique pieces of the invader, we call these antigens, are captured by specialized cells. Think of these antigens as the enemy's uniform or a specific logo that identifies them. These messenger cells then grab the antigen and travel to the nearest command center, a lymph node. This is ground zero, where the adaptive immune response really kicks off. Now, inside that lymph node, there's basically a boot camp full of inexperienced immune cells called lymphocytes, and they're just waiting for orders. The antigen is presented to them here, kind of like a most wanted poster is shown to a room full of detectives. This briefing activates the exact cell that is perfectly designed to fight this one specific pathogen. And this is where we meet the heroes of our story today, the B lymphocytes, or as we call them, B cells. These are the special forces of your humoral immune system. They are the master weaponsmiths of your body. So what makes B cells so special? Well, they're the cells that actually produce antibodies. But here's the really mind-blowing part. Every single B cell is pre-programmed with a unique receptor that recognizes only one specific shape of an antigen. Your body doesn't invent a solution when it gets sick. It already has this massive library with millions of different B cells, each one like a unique key, just waiting for the right lock to show up. So where does this massive, diverse army even come from? This diagram shows us their origin story. B cells are born and they're educated in your bone marrow. And the way your body creates this huge variety of cells, and this is a key learning objective, is through a really clever process of shuffling gene segments. It's like a genetic slot machine that can create billions of unique combinations, making sure we have an army ready for almost any threat imaginable. Once the perfect B cell is activated in a lymph node, it's go time. It starts to multiply like crazy and turns into what we call a plasma cell, which is basically a full-blown antibody factory. And these antibodies are the weapons. I want you to think of them as highly advanced, smart missiles designed for one target and one target only. Let's take a closer look at the design of this weapon. An antibody is a Y-shaped protein, and it has two supercritical parts. The very tips of the Y make up the variable region. This is the unique part, the part that physically latches onto a specific antigen. It's the smart guidance system of the missile. Then you have the stem of the Y. That's the constant region, and it acts like the warhead. It determines how the antibody is going to eliminate the threat once it's locked on.
So what happens when these missiles hit their target? How do they actually work? Well, there are a few ways, but here are two key ones. First, blockade. The antibodies can literally swarm and coat a virus, physically blocking it from being able to enter your cells. If it can't get in, it can't infect you. Simple as that. Second is aggregation. Because each Y-shaped antibody has two arms, it can grab multiple pathogens at once, clumping them all together. This makes a nice, big, juicy target for other immune cells to find and destroy.
Okay, so the battle is won. Great. But the adaptive immune system's work isn't over yet. In fact, its most important job is just beginning.
It's not just about winning the current war, it's about making sure you can never be invaded by that same enemy ever again.
And this right here is the ultimate payoff. Not all of those activated B cells become antibody factories. Some of them turn into long-lived memory B cells. These are the veterans of the war. They circulate in your body for years, sometimes for your entire lifetime. And if that same pathogen dares to show up again, whoa, these memory cells launch a response that is so much bigger, so much better, and so much faster than the first time around, you often neutralize the threat before you even feel a single symptom.
So why is this memory so incredibly critical? To really appreciate its power, we have to look at a world without it. This is the mummy of Ramses V, who likely died from smallpox over 3,000 years ago. For millennia, humanity had no defense against viruses like this, because every single infection was like fighting the battle for the very first time.
Without that immunological memory, diseases like smallpox were just devastating. The most severe form had a terrifying mortality rate of 30 to 35%. It was only when we learned how to harness our body's own memory system through vaccines that we turned the tide against one of history's greatest killers. And it's not just smallpox. The exact same story applies to polio. Before a vaccine, for those unlucky enough to develop paralysis from the virus, about 10% died when their breathing muscles simply failed. It is our understanding of humoral immunity that has relegated these terrible diseases to the history books.
So you see, understanding humoral immunity isn't just academic. It's the science that has saved hundreds of millions of lives. The core principles we talked about today, specificity, memory, B cells, and antibodies, are the foundation of vaccination and so much of modern immunology. And that leaves us with a really powerful question. Now that we've unlocked the secrets of this amazing system, what is the next great challenge we're going to conquer with